Hello, lovely Year 4s. Happy Wednesday. Now, because today is Wednesday, we get to do a very exciting science investigation today. Just like we did last week, you will need a few resources, but please don't worry if you don't have access to them. I have adapted some of these, some of them I don't have, but that's absolutely fine. Please do not panic. So the list of resources, if you have them, are going to be as follows. But to begin with, please ask your adult at home to help you find them. And if you are panicking that you don't have something, you don't need to, okay? Trust me, everything is going to be okay. I will show you in the video anyway. So to start with, you need an empty plastic bottle with a lid. Any size, any shape, just as long as it's empty. So don't pour out anything, and as long as it's got a lid. Okay, number 2, you need a balloon and some scales. Preferably electronic, but that doesn't matter. I've not got electronic scales. I'm not going to buy them especially for this. So whatever you've got at home that you might use when you're baking or something is perfect. If you don't have any, once again, don't worry. Even if you just have a plastic bottle, that's great. Task 3, you need an essential oil and paper towel or tissue. I'm using an essential oil, but you could also use Olver's oil as if you've got a cold. You might have some of that lingering around at home. Make sure you ask an adult. And then task 4, you need some water, 3 containers. They don't even have to be matching, mine aren't. Sand, gravel, marbles, a magnifying glass and a sponge. Now out of this list, I don't have a magnifying glass with me, but don't worry about it. You should be able to see some of it or most of it with your eye. And I've not got marbles here with me because I want you to tell me what you see happening. But if you've got them at home, or if you've only got 1 or 2 of these, go and grab them. If you haven't, like I've said, don't worry. And once again, as a little reminder, take care with spillages and use them away from electronic equipment. I've got some water here next to my laptop, not feeling great about it, so be careful, okay? I've kept it to one side, so if you're using your iPad or whatever you've got, a laptop, keep it to one side and away from the liquid. Need to be really, really sensible. Okay, so to begin with, we've got some total recall. So this is from when we were learning about the digestive system, and we were learning about the different teeth we have and their different functions. So pause the video here, see if you can call out the different types of teeth, and a bonus point if you can remember their function. Okay, so we've got our incisors. Do you remember how many we've got? Our canines. Do you remember the function for the canines? We've got our molars. We've got our premolars. And again, we've got our incisors and canine. Now, bonus point if you can remember the different uses of these teeth, because each of them have a different function. Okay, so I'd like you to write the date and the title into your book and underline it. You'll notice that we have different WILFs today, so please write WILF as well. And we are going to be going through those different WILFs when I start you off on your task. Okay, great job, team. Now, as we saw last week, we have our states of matter word mat here. Now, starting from the left again, let's go through these together. We've got solid, liquid and gas, and I'm hoping, guys, that by now you're able to tell me something about the different particles. We are going to recap that in a minute, so don't worry, but maybe test yourself now. Can you remember how the different particles react or behave in the solid, a liquid and a gas? Then we've got state change, melting, freezing, and we are going to be doing an investigation on this when we're back in school, so it's very exciting. Then we've got melting point, boiling point, evaporation, temperature, and the water cycle. And we are going to be learning about the water cycle. Okay, fantastic effort. So today we are imagining, because we are thinking about scientific concepts and then we are practically experiencing them. So we are seeing how something might work, and then we are going to practically experience them as well. So a lot of exciting learning today for science. So a quick recap. What are states of matter And what are particles? So we learnt last week that everything on Earth can be categorised into a state of matter. And the most common we talk about are solids, liquids and gases. So we can explain the differences between solids, liquids and gases by knowing what they are made of. Because scientists have found that all materials are made of very teeny tiny particles, and these particles are something that we cannot see with the naked eye, and not even with a microscope. Now, scientists have learned that the position and the behaviour of the particles is different in both solids, liquids and gases, like we were discussing earlier on. So here are how particles look in a solid to begin with. Now you can see here that in a solid, on the left, particles are super close together, they are of a regular arrangement, and they vibrate about a fixed position. So they're moving, but they are in a fixed position. Then in the middle, we've got our liquid. Now this is what the particles look like in a liquid. They are still close, but they're randomly arranged. They are different to that what we can see in a solid. Can you see how they're different? And they also move around each other. Now lastly, gas, and that's what we're focusing on today. How does a gas look different to that of a solid and in a liquid? Now you can see in the gas particles that they are far apart. They will randomly arrange themselves and they quickly move in all directions. So we're going to learn about gases today, and I'm very excited to share this with you. So let's look at the properties of gas. Now particles are spread out and they can move about quickly in all directions. So they are very different to a solid and a liquid. They don't keep shape. They can spread out to fill the space it is in. Gas can flow. Gas has no fixed volume and it can be compressed. So those are all the different properties of gas. So gases surround us, but how many can you name? Which ones make up the air around us? And which gases are important for human life or plant life? Now I think it's brilliant if you could be making links to your learning that you've already done. Making links is one of our learning powers. So even if you think of only one of these, can you think of some? Can you name any gases that you know of? Which make up the air around us? Because I've got some slides coming up which discuss these. So see if you have got some of these right. Okay, so we've got air. Air is a gas all around us, and it is a mixture of several different gases, mainly nitrogen and oxygen. So we can't breathe without air, and plants can't photosynthesize, which is a process that plants use to make energy. We've got air which supports balloons and aeroplanes, inflates bicycle tyres and turns windmills. Now I will not go through each of these step by step because I think that some of you guys might just end up skipping, which I understand. So if you'd like to, pause the video here and spend some time learning about the different gases around us. We know that oxygen is incredibly important for us too, and the air around us is 1/5 oxygen, which I think is pretty exciting. Then we've got some learning about the ozone layer, and this protects Earth from the sun's potentially damaging UV light, which is why we use sun cream. Then we've learning about carbon dioxide, nitrogen and nitrous oxide. So if you want to pause the video again, then please do so. And interestingly guys, carbon dioxide is what we use in fizzy drinks to make them gassy, to make those little bubbles. That's carbon dioxide. And lastly, we've got water vapour, helium, argon and neon. So pause the video and have a read if you'd like to. And just importantly guys, we want to think about vapour today because we are learning about vapour in an essential oil. I am going to post a video in the YouTube description, so click on that video because the video shows gases being used in everyday life. How many can you spot? Are there any that you recognise? If there are, you can write them down neatly into your books and then we're going to reflect on them in the video. Okay, so we've learned that moving air can be very useful. It turns wind turbines, it blows washing on a washing line, or it fills the sail of a yacht. But it can also be damaging. All materials are made up of particles, solids, liquids and gases. And even though many gases are not visible, we cannot see them, we know that they are there and that they are matter. What you could do, for example, is blow on your arm and you will see the tiny hairs. They will be moving, but you can't see the gas, but they are definitely there because the hair is moving. We will carry out some demonstrations to show that air is a material. Isn't that amazing that air is a material? Okay, so I'm going to be flicking back and forth from the visualizer to the screen, so bear with me. But what you need to start with for task 1 is your plastic bottle. Okay, that's the only thing that you need for now. And the question that we're asking today is this plastic bottle empty? And then once you've got your plastic bottle, I want you, with the lid tightly on, to try and squash it flat. Now here is my plastic bottle, and I can try and squeeze it, but there is no way. There's a little bit of give there, but even though it looks empty, I cannot squash it flat. There is no way. I'm trying my hardest, but it's not working. So why can't you flatten it? Because it looks empty, doesn't it? But although the plastic bottle is empty of liquid, it is full of gases. That's why we cannot squash it flat. So the air inside is stopping you from squashing it. So take the lid off the bottle and try squashing the bottle now. Tell me what you see. So I'm going to do it as well. Taking the lid off. What do you think? Do you think I'm going to be able to squash it flat now? Absolutely. I can squash it flat now because the gases are able to escape. I must say, guys, so if you have got a plastic bottle, make sure that you're recycling it. Otherwise, this is going to be around for hundreds of years. Recycle it. Okay, I'll put it back there. So what do we learn from that? What I want you to do is explain to somebody at home what happened in order for you to be able to flatten the plastic bottle. Okay, go and do that and then come and join me in a second. Right, we are next going to learn about whether gases weigh anything. What do you think to begin with? A higher order question. Do gases weigh anything? So you're going to weigh an empty balloon and then inflate it and weigh it again. So back to the visualizer. Here is. See, I don't have a fancy electronic one. I much prefer this, but that's just me. So you've got to make sure that your dial is set to 0, otherwise that's not going to be fair to begin with. Pop it in, and this has gone up. Oh, hang on, I need to get it set straight. It's the only fussy bit with this bit, isn't it? Okay. It's gone up a teeny tiny, maybe ½ pound. It has increased in weight. So now, let's blow it up. You could, if I was on a Blue Peter program, then I would say here's one I did earlier, but I've only got one balloon. It's escaping. Okay, that does not taste very pleasant. I wonder how long I've had this balloon for. Okay, so before it was on about ½ pound. Now let's see if it's increased in weight. Now, yes, it has. I'm not sure how clearly you can see this on the visualizer, but it's now increased by a little bit more, what can we learn from that? This shows us then, guys, that the air forced into the balloon under pressure is matter and therefore makes the inflated balloon heavier. It doesn't weigh that much, but it definitely does, and you'll be able to see that even more clearly if you've got electronic scales. Tell me if you can on a sway or something, or on our teams, perhaps you could tell your teacher what you started out with, and then after you've blown up your balloon, what was the weight afterwards? Okay. Now we've got task 3. Now I'm just going to shuffle everything. I told you it was faffy, team. Okay, task 3. We're now going to learn about how smell travels. So first of all, have a think to yourself. How does smell travel? So what I want you to do is ask an adult to place 1 drop of a scented oil onto a tissue. So for example, here I've got, this is some orange essential oil, but you can use, like I said earlier, you could even use Olbas oil, because that will also show you the same thing. Now, when you're working with essential oils, you'll only need a few drops. Get an adult to do this if you want. Goodness me, I can already smell it. It smells amazing. So 1, you can see that, it's not very clear, is it? Here it is, just here. And 2. So that's a bit clearer now. You can see my essential oil. Pop it to one side, put the lid back on, because no one likes oil when it's spilt. What I'd like you to do is ask an adult to hide this somewhere in the room, and you're going to be using your sense of smell to try and hunt it down. Do not watch where your adult has hidden it, because that is cheating. We don't want any cheating. Okay, so like we've just said, whilst you close your eyes, your adult must hide the tissue somewhere in the same room. Now, using your sense of smell, you must hunt for the tissue. Okay, you are now on this hunt. So can you notice when the smell gets stronger? And then what I'd like you to do is think about the movement of gas particles and use scientific language to explain how the smell travels. And a little hint, I want you to think about the particles in gas and how they behave. So particles in gas, they are free to move in all directions. So the oil vapours, like we mentioned earlier, turn into gas and spread around the room. They don't just stay in one place like a solid would, because we know that gas particles move quickly and rapidly, and they don't behave in the same manner. Okay, so that's why you were able to hunt. It might have taken a little while, but why you were able to hunt the oil, the essential oil, on the tissue paper, even though you didn't see where your adult hid it. Okay, fantastic job. So, task 4. On the Earth's surface, air fills every available space, even those tiny spaces between and within solid objects. But you might be thinking, Miss Marget, you've been away from school for too long. What are you on about? Let's see if we can find some evidence of this. So, with the 3 different solids that I asked you to get earlier, with the sand, gravel and marbles. Remember, I don't have marbles, but if you could find something, that's fantastic. If you can't, don't worry about it. We can talk through what we think we might see. What I'd like you to do is slowly pour water over your sand, and then with a magnifying glass, don't worry if you don't have one, can you describe what is happening? Now, I don't have a magnifying glass, but I do have my visualizer, so I'm hoping that this is going to work. So remember, guys, that we are testing whether there is evidence that air fills up every available space, even those tiny spaces between and within a solid object. And we learned last week that although we can pour sand or sugar, it's still a solid. So we're going to see if we do really have gas, even in those tiny spaces between and within solid objects. So let's try this. There's a scratches on my mug as well, so thanks. Is that better? Yes, that's much better. Okay, are we ready? I'm going to start pouring in a second, and you're going to be looking to see what we can see. Got a little bit more. What do you notice? I can hear them. There we go. Fantastic. You can even go and do that down at the beach. What does this show us? This shows us that there is air, gas, the air is being pushed out of this solid. So therefore we know that air takes up the space in between even solid objects. And we could see that by the little air bubbles that were released. Okay. So here we have it. Bubbles of air or gas escape as water fills up those spaces. But where do the bubbles come from? From the gaps between the solids. Okay. We can also do that with some water. Sorry, I'll pause there because I've got a rather large container of water here. And a sponge. Now, like I said earlier, you need to be so careful with this, guys. Please, please, please have an adult with you on hand. We don't want any water spillages. Now I've got my sponge. What is a sponge? Is it a solid? Is it a liquid? What is it? I'm hoping you're saying that it is a solid, but we are going to try and prove that air or gas is in between even the tiny, teeny spaces of solids. So let's see. What do you think we'll be looking for again? So like we did with the sand, we saw air bubbles. Let's test this. I'll give it a squeeze. Can you see those air bubbles escaping? Let's try again. I have to empty it out. Can you see once again those air bubbles escaping? Guys, be so careful of all this water and things that we've got around. Right, my fingers are too wet to even use the mouse pad. Be so careful. So where are the bubbles coming from in the sponge? They are coming from the spaces and gaps within the sponge. It's a very special material, is sponge. Okay, so what I'd like you to do is using the sand, the gravel and the marbles, you are going to bronze, you're going to use scientific vocabulary to annotate scientific observations, so what you noticed. For silver, you're going to confidently use scientific vocabulary to annotate or label scientific observations. For gold, oh, this is frozen, there we go. You're going to use scientific vocabulary to explain scientific observations. And then for challenge, if you'd like to, from memory, draw the particles in a solid, liquid and a gas and label the properties of each. So what do you notice in each of those? So this is what you're going to use to help you. Record what you observed through annotated drawing. So you're going to draw and label what you noticed. Look closely using the magnifying glass. Make sure your sketches are as detailed as they can, and describe what they have seen using scientific terms. So you can use this sentence stem to help you. When I pour water over, so for example, the sand, I noticed that. Then what you're going to do is then you're going to try out the gravel. When I pour water over the gravel, I notice that. And then the same for marbles. You could use an alternative solid if you'd like to, as long as you've got your adult's permission. Then what I'd like you to do is draw a picture and label it using scientific language, such as gas. And then for gold, you're going to tell me this shows that. And you're going to tell me what we learned through that today. Now, just in case you don't have access to, not that one, to a different solid and liquid, let's have a look at the gravel, just so you can write about two different things, the sand and now the gravel. So in goes the water, very sensibly pouring. Now, I think some of those were from me pouring into the jug, but I can also see some of the bubbles of the gas that were in between pieces of gravel. So, folks, if you have access to the marbles or a different solid with your adult permission and support, then give that one a go. So what you're doing is then following the instructions on this page, and then join me in a minute for a pit stop. So pause the video, use my sentence stem, draw that picture and annotate it using scientific language of what we saw when we poured the water over the sand, the gravel, and alternatively marbles if you're using them, and let us know what you saw. Okay, so these are really cool. These are called concept cartoons, and somebody in this picture is right and somebody in this picture is wrong, correct and incorrect. So let's start with Ben. I can see a liquid and a solid in this picture. And Jenny says, I can see all three states of matter in this picture. Now, what are the three states of matter? I'm hoping you're saying solid, liquid and gas. Now, here's our picture. Who is right? Who is wrong? Pause the video. Who do you agree with and why? Okay, so I'm hoping that you agree with the lovely Jenny, because we know that gas will try and make its way into anything. It surrounds everything and anything where there is no liquid or a solid. Okay? So gas is all around us and it makes up everything around us where there is no liquid or solid. Ben, sorry pal, you're not correct. Keep trying though. So carry on with the investigation and the writing and what you've observed, or join me now for a quick plenary. So there are three states of matter: solid, liquid and a gas. Just to recap, if you'd like to, you can make a quick glossary in your book to help you remember these. Just write a quick sentence underneath. Okay, well done, lovely guys. This has been quite an exciting experiment and investigation that we've done today. If you've got any questions or anything that you're wondering, please ask your teacher. There is a teacher on duty today. You've done a fantastic job. Well done for sticking with me. Have a great day. Put everything away very sensibly and back where they belong. You might even want to do the dishes to test out the old sponge and water. Okay, take care guys. Bye.